So one application that we can use vector projections for is what's called to find a force of a vector. Or if you're talking about a force, then the projection of u onto v represents the effect of that force action in the direction of v. So for example, if you push a box uphill in the direction of v with a force of u, the effective force is a component push in the direction of v, which is the projection of u onto v. So again, we can use vector projection to find a force. So here's an example. You have a 3,000-pound car that's sitting on a hill inclined at 30 degrees as shown. So as you can see, the incline is 30 degrees with the horizontal. Ignoring the force of friction, what force is required to keep the car from rolling down the hill? So when we talk about the force that's required to keep the car from rolling down the hill, that is this particular vector here, which is our W sub 1. Sometimes they may ask you to find the force perpendicular to the hill. That is your W sub 2 vector, which is right here. So now, instead of using the vector projection formula, you have enough information actually to go back and use your right triangle trigonometry. So since this force, the W sub 2, is perpendicular to the hill, we know this angle inside this triangle is going to be a 90-degree angle. This angle here is 30. The weight of the car is 3,000 pounds. So that's actually the magnitude of the force of this third vector. So I can label the sides of my triangle as 3,000 pounds. And this actually is perpendicular to the horizontal. So since this angle is 30 degrees, I know this angle up here has to be 60 degrees. Because all three angles inside this triangle are going to add up to equal 180. So now if I redraw this triangle, let me do it this way. Again, there's that perpendicular, there's that W sub 1, which is right there, the slope on the hill. Here is the hypotenuse, which is the weight of the car, which is 3,000. And there's W sub 2. Again, I know this angle up here is 60 degrees. So then to find W sub 1, again, W sub 1 in relationship to 60 degrees is my adjacent. I know the hypotenuse, so I can set up the cosine of 60 degrees is equal to the adjacent over the hypotenuse. And then I can multiply 3,000 by the cosine of 60 degrees. So that gives me 1,500 pounds. If I want to find the force perpendicular to the hill, my W sub 2, I'm just solving for this side of my triangle. So in this particular case, in relationship to my 60-degree angle, I'm going to set up the sine ratio. Sine of 60 degrees is equal to W sub 2 over 3,000. So 3,000 times the sine of 60 degrees is 2598.076 pounds. So again, they may ask you to solve for the force that's perpendicular to the hill as well. This is the force required to keep the car from rolling down the hill. So here's another example. We have Mary sitting on the sled at the side of a hill inclined at 60 degrees. So again, that we have the 60-degree angle with the horizontal. What force is required to keep the sled from sliding down the hill? So here's my sled. And again, the sled is 125 pounds. So here's my W sub 2, which is perpendicular to the hill. Here's my W sub 1, which is the force that's required to keep the sled from rolling down the hill. The weight of the car is perpendicular with the horizontal. That's the weight of the sled, which is 125 pounds. So again, I've got two right triangles right in here. This one, this larger one, this angle up here has to be 30 degrees. So again, if I redraw my picture, there's that 30-degree angle. Here's W sub 1. Here's the weight of the sled, that's 125 pounds. And there's W sub 2. Again, W sub 1 is the force required to keep the sled from sliding down the hill. So again, in relationship to 30 degrees, if I solve for W sub 1, I'm going to set up the cosine. So the cosine of 30 degrees is equal to W sub 1 over 125. So I can multiply 125 by the cosine of 30 degrees, which gives me 108.253 pounds. That's the force keeping the sled from rolling down the hill. If I wanted, again, if the question asked me for the force perpendicular to the hill, I would then solve for W sub 2.